Hello everyone. All right, so we're going to go through uh, the rock cycle. You guys put together your questions, or sorry, you emailed me your questions and I put them together in a big document and I sorted all your questions out and kind of grouped them up into different sections. So what we're going to talk about in this video is just those questions that are focusing specifically on the rock cycle. Not so much each individual type or some of your overall general questions. We're just going to focus specifically on the rock cycle. Okay, so if you take a look here, I went ahead and filled in our 3 types of rocks on here. One of the questions that I got was, why are there only 3 types of rocks? And that's a fantastic question that I don't really know the answer to. A short answer. A longer answer would be, well, that's just based off of hundreds of years of research and evidence and looking at rocks that are thousands or millions of years old. This is kind of some of the characteristics that we have been able to identify are different common things that we see, like in sedimentary rock. These are the ones where we're going to find fossils. In igneous rock, these are the ones where we either see crystals or we don't. Metamorphic rock is, it can have a little bit of this crystallization, but you're also going to have some what they call banding, which isn't really like sedimentary rock, but it is in the sense that you can see some layers, kind of, sort of, in a way. Okay, and yeah, so why just 3? Well, that's just what we have right now. That doesn't mean that there's always going to be 3. Just like with space, as we discover new information and we get more clear pictures and data, we refine what we know. So as we learn more about Earth, or maybe even Mars geology, we may discover that Mars has 4 types of rocks or 2. It just kind of depends. Okay. Now you'll notice that I went ahead and I filled in the types on here, and these are not in any specific order. In fact, in the rock cycle, unless there's pictures like a mountain or something like that associated with it, it really doesn't mean anything as to where they go. Okay, so let's just start up here at the top with igneous rock. Now this is another question that I got, was, does it matter where we start in the rock cycle? And the answer is absolutely not. You start where you are. You start with the rock that you're looking at. Okay, so if I'm looking at igneous rock, and an igneous rock has either been dug up or it's been exposed to the surface. Okay, so what is going to happen to that rock as it is exposed to air? It is going to go through the process of weathering and erosion. Now, they are different. Okay, weathering is going to have to do with wind or air and water. This is going to break down a larger rock into smaller pieces. Okay, so weathering is breaking down, I'll add that on here, breaking down into smaller pieces. Now, those smaller pieces usually get moved, whether it be, I mean, if you think about it, dust in the air is, at one point in time, was a rock. Okay, so weathering is the breaking down of it. The movement of those small pieces is erosion. Okay, so weathering and erosion breaks down larger rocks, into smaller things called sediments. Notice a similarity here. Okay, sediments are those smaller pieces. Now, you may have things stuck in this cycle. Okay, maybe not so much this cycle. More of this cycle here, weathering and erosion, and getting smaller and smaller and smaller. You may have things here for thousands or hundreds of thousands of years. Okay? It's not just the big boulder that's broken down into a smaller boulder and then it automatically becomes something so small it gets turned into a sedimentary rock. Guys, this here has, I'm trying to find a pencil. This here can have a cycle amongst itself. Okay, back and forth and back and forth. Okay, now those sediments are going to layer on each other. So let's say that you have your sediments at the bottom of a lake. Okay, let's see if I can draw something here. So I've got my lake. Okay, lake. Okay, and at the bottom of the lake, I don't know if you've gone fishing while we've been out on quarantine or anything like that, but you have your mud at the bottom. Okay, and then you'll have some other stuff layer on top of that. And then you'll have some other stuff layer on top of that. You kind of get the point here, right? Okay. And over time, what happens is more and more of these layers build up. And you really can't tell these are layers because I'm not drawing them thick enough. Okay. Okay, so you're going to have layer after layer after layer of stuff on top of each other. And after a while, all of these things, kind of like with that Edpuzzle video that you watched, there's a lot of weight that comes with this, and there's a lot of pressure pushing down. Okay, now what turns sediment into sedimentary rock is two things. Okay, sediments get compacted, okay, which means pushed together. Okay, you can have things pushed together all day long. You can take a stack of papers, 3,000 sheets of paper high, and you can stack them on top of each other and you can push down. But as soon as you let go of that pressure and the wind blows, those papers are going to go away. Okay? Now, what makes sediments turn into rock is this part. Cementation. Now, a concrete truck does not roll up and pour concrete into here. Okay? What happens is as these things are pushed together, there's so much pressure that's pushed together that things start to change on the atomic level. You start to have, so think of it like if you pushed enough, okay, think about fruit, okay? Fruit that you usually think doesn't have a lot of juice in it. I don't know, apples, I don't know, that's all I can come up with right now, okay? Apples don't have near as much juice as, say, like an orange. Okay, but if you put enough apples together and squeeze and squeeze and squeeze and squeeze and squeeze, you're going to start to get some juice come out. Okay, and the cementation of these sediments right here is what's going to actually cause it to stick together like cement. That's there for a reason. So sediments go through compaction and they're cemented into sedimentary rock. Okay. Now, that sedimentary rock can also, I may have in here, I may have a dead fish. That's supposed to be a fish. Pretend that's a fish. Skeleton. Okay? So I may have a fish skeleton in there, and as it gets pushed and pushed and pushed and pushed and pushed together, you're going to have fossils. Okay? So there's that part of this. Now, sedimentary rock itself can also go through weathering and erosion, okay? And it can go through its own cycle of weathering and erosion, and you may have a rock that just stays here for millions of years, okay? Or you may have this sedimentary rock, as this forms, it gets pushed further and further and further and further down into the earth, closer to the mantle, and as it gets pushed down, it heats up. Okay, so you can have sedimentary rock that has heat and pressure applied to it, and that heat and pressure is going to turn it into metamorphic rock. Okay, or you could have it go through its own, like I said, or it could go back to here and just stay in this cycle. Okay, but let's pretend that we have it coming over here into metamorphic rock. Okay, so there's that one. Now, metamorphic rock, once it's exposed at the surface. Now, we're not talking metamorphic rock that's like 200 miles down. No, we're talking about the metamorphic rock that gets either dug up or, which you can't dig 200 miles down. You can dig maybe, they can dig maybe about 30 or 40 miles down, okay? Usually not even that deep. But metamorphic rock can go through weathering and erosion. It typically takes a lot more of this to make sediments, okay? To make sediment, and then the sediment gets compacted and it goes back into sedimentary rock. So that can happen. Sedimentary rock is usually what they consider I'm going to use the word weak, but it's not really weak. It's still rock. I mean, it's still hard, okay? But metamorphic rock is really strong, okay? Because it has been heated up and stretched and pressurized and all that other sort of stuff, okay? So metamorphic rock can also melt. Okay, I should have used a different color. Let's use hot pink. Okay, metamorphic rock can also melt. So when it gets heated up and pressurized and turns into metamorphic rock, it's close-ish to the mantle, but it's not like to the point where it's going to melt into magma, okay? But as it gets pushed down, because as the tectonic plates move, which we'll get into that later, or as more and more stuff gets layered on top of it, it gets pushed closer down to the mantle, so it's going to melt into, I should have wrote this the other way, melting into magma. Whoa, I can't spell. Okay, melting into magma. And that magma is going to cool at some point. I need a blue. Okay. It is going to cool and form igneous rock. Forgot one. Rises to surface. Now, as it rises to the surface, it will either break through the surface and become extrusive igneous rock, or it stays below the surface and cools, becoming intrusive igneous rock. But either way, we've got magma rising closer to the surface. It's going to cool off and it's going to form igneous rock. Okay? Now, this igneous rock can also stay in this loop as well. Like in Hawaii, okay? Or places where you have consistently erupting volcanoes and you have lots of lava. You may have lava that was, okay, I'm making this up, but let's just say that something erupted 2 months ago and there was lava covering the field. Well, that volcano may erupt again today and cover that same lava field with new lava. Well, the lava from 2 months ago that was starting to cool is going to remelt. I realize it's not called magma anymore, it's lava, okay? But it's going to remelt and cool, and igneous rock and remelt and cool, and so it is totally possible for it to do this. So you may have in Hawaii, especially, or places with very active volcanoes, you may have rocks that stay in this part of the rock cycle millions of years. One question that I got was, where did it go? How long does the rock cycle last? Or how long, I can't remember the exact wording, but essentially like how long does this last? Well, guys, every piece of, okay, not every piece, 95% of the rocks on this planet, and that estimate may be high. Okay, 90%. We'll go with 90%. 90% of the rocks on this planet are the age of the planet itself. Okay, so we're talking 4.6 billion years old stuff that make the rocks. So how long does this last? Well, it started 4.6 billion years ago and it's still going. Okay? And why did I say 90%? Because there have been things like asteroids, meteorites, things like that have brought different rocks into our planet that were not there when it was formed, okay? But every single rock on this planet right now is going to continue going through this as long as our planet is in existence, okay? All right, so you can have a metamorphic rock melt into igneous rock. You can have a metamorphic rock weather and erode and become a sedimentary rock. You can have a metamorphic rock just stay a metamorphic rock, okay? Igneous rock can also have heat and pressure applied to it, and it can become, a metamorphic rock, okay? So I hope, let's see, I'm gonna go through my questions. Does every single rock go through the complete rock cycle? No. How they end up connecting to one another? Well, it just kind of depends. I mean, they can go through each place. If we would have been in class, there's this game that we play where we roll dice and you take on the role of a rock and you follow around the room into the rock cycle. Now, I can't do that because, well, we aren't in class right now and not everybody has a dice and all those other things. But anyway, so some people would literally stay here. Actually, there were some people last year when we did this that they went back and forth between weathering, erosion, and sediment 25 times. Not very fun for them. It was like one chair to the next, 25 times, back and forth, back and forth. And then you had some people that went through the entire thing and became all three. Okay? What happens if the rock cycle just stops? Then what happens? Well, it's not going to just stop because this constant heating and movement of the surface of the earth is constantly happening. So if it just stops, then our planet has ceased to exist and we're probably dead by then. So it's probably not something you worry about at that point. Let's see. Can any type of rock get melted into magma? Absolutely. Okay. If I get sedimentary rock, for some reason, let's say that there's a volcano that opened up in the middle of Kansas City. I hope that doesn't happen. But let's just say hypothetically that it did. Kansas City has tons of this type of rock. That's why we have all the caves. Okay. That's why we have some of the greatest, we have a lot of lakes, like the Lake of the Ozarks and stuff. That's all because we have so much sedimentary rock that's been eroded over time that we have these huge lakes. And also we made some of them. But anyway, so if we had a volcano form, just open up in the middle of Kansas City, you're going to have a lot of this type of rock melt into magma. Here's my magma. Okay, and we're going to have a lot of this happening. Okay, let's see. If any of the rocks can be destroyed or formed again, but differently, like in different types of rocks. Absolutely. Okay, if I were to, I wouldn't do this, but if I were to take a chunk of limestone with me to Hawaii, whenever I go, and I threw it into the volcano, which first of all, I would never get that close. Second of all, I wouldn't waste the space on my luggage to take a hunk of limestone with me. But anyway, if I threw a hunk of limestone, which is a sedimentary rock, into a volcano for it to melt into lava, then yes, I would change it into a different type of rock. Okay, so I think that's all the questions about, how long does it take to go back to magma going through the whole cycle? Ooh, I don't know that. I'm going to have to look that one up. That's a very good question. I'm going to pull this one off to the side. Okay, so there's that on the rock cycle. I hope this has helped, and good luck. So check out the rest.